Welcome back to Cali Water Ag's San Joaquin Water and Land Use series. For those of you joining Cali Water Ag for the first time, welcome. My name is Vicky Espinoza. I'm a PhD candidate at UC Merced. In part 1.4 of the series, I will talk about strategic land repurposing for addressing groundwater overdraft. Before we begin, I'd like to introduce my doctoral work. My research focuses on analyzing the Sustainable Groundwater Management Act, or SGMA's impacts on land use changes, and how these land use changes could impact our communities, our farmers, the economy, and the environment. The significant future of land use decisions lies in the hands of the local community, and to achieve stability, we need your involvement. I need your help to develop innovative land use strategies that make our communities stronger and more resilient to water scarcity. Through my research and community engagement, I've learned through hundreds of conversations with growers and community members that the real problem is groundwater overdraft. Historically, we have been advised of the limitations of our most limited resource, water. Groundwater overdraft is one of the most complex situations that we have ever faced. Through conversations with growers and communities, talking about land repurposing is difficult for many reasons. However, farmers and communities will play a major role in changing the outcome of groundwater overdraft. Local innovative farmers wanting creative solutions, along with multiple organizations, are coming forward with solutions like land repurposing. In this video, I will go over some of those proposed solutions. Let's get started. In this video, I will recap why SGMA passed, how SGMA could impact land use, how land repurposing projects get done, and upcoming opportunities to hear your input on these land repurposing options so that we can co-develop future land use solutions that are resilient and representative of your and your community's needs. The Sustainable Groundwater Management Act, or SGMA, passed because groundwater is being pumped faster than it can be replaced. Decades of unmanaged groundwater pumping has led to domestic wells going dry, as seen on the map on the right, where the red dots indicate wells with groundwater levels decreasing more than 10 feet. With GSAs, growers, and community members working together, we can make most of those red dots on the map green again. Excessive pumping of groundwater has led to the drying and disappearance of rivers and wetlands that are vital for migratory birds. The San Joaquin Valley is a midpoint of the Pacific Flyway. The Pacific Flyway extends from Alaska to Patagonia and provides food sources for birds heading toward breeding grounds and overwintering sites. Sinking lands, damaged roads, and canals is a result of groundwater pumping in the valley. Curbing this overdraft will require substantial reductions in pumping over the next 20 years, which will significantly impact the agricultural sector and rural economy in the Central Valley. For more information on the Sustainable Groundwater Management Act, see Part 1.1 through 1.3 of this video series. There is potential fallowing of agricultural land to address groundwater overdraft issues in the San Joaquin Valley. Agriculture is by far the greatest use of groundwater in the valley, so pumping restrictions will most significantly impact the agricultural sector. In order to avoid the undesirable outcomes of overdraft, groundwater pumping will have to be reduced by about 16%. This will likely result in fallowing of about 15% of agricultural land, or about 500,000 to 750,000 acres over the next 20 years. Deciding which land to fallow is difficult, and is not something that should be done randomly. That is why it's important for you to become involved with your Groundwater Sustainability Agency, or GSA, to inform future solutions to SGMA in your region, and stay tuned to Cali Water Ag for opportunities to co-develop the strategic land repurposing model that I am developing. If land is to go out of production, leaving the land fallow or without use will not benefit the grower, the economy, the environment, or the health of the surrounding communities. Fallowing land leads to loss in agricultural revenue and jobs. It increases pest and weed invasion and increases dust emissions, which could increase risk to valley fever in some places, asthma, and heart disease. Moving forward, your involvement and coordination are important. Coordination can help facilitate beneficial land repurposing so that agricultural land that can no longer be irrigated can provide real economic, environmental, and societal benefits. Before we dive into the alternative multi-benefit land repurposing options currently considered, I would like to clarify some terms that you may encounter. Some of these terms include idle land, fallow land, retired land, and land repurposing. Although these sound similar, they have very different definitions that lead to differences in future outcomes of previously irrigated lands. Idle land or fallow land is land that is cultivated but is currently in a state of disuse. Irrigated land can be left idle temporarily. Retired land is land that was previously cultivated but is no longer in use. Retired land is permanently fallowed. Land repurposing is a fairly new term. It specifies an alternative land use management plan that gives fallow land a new value, while also reducing water use. It could help reduce poor air quality, water use, and the loss of revenue and jobs that result from fallowing or retiring agricultural land. Some alternatives could work together with agriculture. These land uses encompass economic, environmental, and societal benefits. Some land repurposing examples include low-impact solar, grazing land, dryland agriculture, groundwater recharge, and floodplain restoration, recreational areas and parks, and habitat for endangered animals. These are just a few examples of what land use alternatives could look like, but we want to hear from you about what you would like to see in your communities. Dryland agriculture provides some revenue, is flexible year to year, can serve as a transition crop, and promotes soil health and has pollinator potential. Some things to consider is that yields can be unpredictable. It is not viable in some regions with limited rainfall. Grazing provides some revenue and can support soil health if managed well, and can be compatible with native vegetation species. This alternative requires investment in fencing, and the amount of feed is dependent on rainfall. Pollinator-friendly cover crops is another alternative. It helps improve soil quality, reduces dust and erosion, and can support pollinators. Some considerations are that seed mixes need to be selected based on local rainfall patterns and soil conditions. Low-impact solar provides substantial revenue. It is a clean energy source and can provide multi-benefits. This option may not be possible everywhere. Ideal locations for low-impact solar require the right physical conditions and accessibility to transmission infrastructure. Habitat restoration provides wildlife habitat, increases soil carbon storage, and there is funding available. Some things to consider when implementing habitat restoration is distance to existing habitat. Connected and large areas lead to more successful implementation, and funding can be difficult to access and is unique to each applicant and field conditions. First-time applicants consider partnering with a local conservation nonprofit, resource conservation district, or Natural Resources Conservation Service office for support. Groundwater recharge helps store water for future use, can improve well reliability, and can also provide habitat and support ecosystems. There are some cases in which groundwater recharge and agriculture can work together successfully in some regions with the right soil conditions. Studies have found that high saturation tolerant crops like rice, almonds, and alfalfa are ideal in some locations to promote groundwater recharge. Parks and green space provides recreational opportunities for communities and can be a buffer against environmental health threats, especially near underrepresented low-income rural communities that are already faced with poor air quality and water quality. Finding places for parks and green space to provide benefits for communities that lack these spaces is something to consider when implementing parks and green space. Alternative land uses could also include shifting to less water-intensive crops. Some benefits are that it promotes water savings. It also keeps specialty crops in production and maintains the crop diversity that coins the San Joaquin Valley the fruit basket of the world. These crops can also be flexible in that they can be annually fallowed during time of drought. Some considerations are labor requirements, changes in revenue, demand in market, and the amount of fertilizer needs of various crops. These are some of the land repurposing options that have been considered for addressing groundwater overdraft, but remember that SGMA is a tool that provides the opportunity to continue to develop creative and innovative solutions to groundwater overdraft. Coordination can improve outcomes, which is why it's important for growers and community members like you to become involved in developing solutions with your GSAs. Here is a purely illustrative example of what coordinated land repurposing could look like. On the left is an example of unplanned fallowing, where the least cost fields are retired first without coordination between neighbors. The map on the right is an exaggerated example of how planned land fallowing could focus retirement in certain areas that allow for land repurposing, in this case, a habitat corridor that connects important conservation areas for San Joaquin animals. Some estimates indicate that coordination, like valley-wide water trading, could reduce land retirement by 1/3, or going from 750,000 acres to 500,000 acres of fallow land, and could save about 6,000 agricultural jobs. One bonus of land repurposing is that they can tap into public and private funding. While there is a lot of funding available, it can be hard to access and generally requires working with a USDA liaison, for example, or a conservation group familiar with grant applications. We will have a workshop in English on January 13th, 2021, and one in Spanish on January 14th, 2021. We will discuss funding programs and we can offer recommendations for contacts based on your situation. To summarize, limited water supply will lead to agricultural land retirement. Without management, fallow land may pose a threat to landowners and communities. Land repurposing is possible, but will require planning, coordination, and stakeholder buy-in, or the involvement of those that make decisions, those that develop solutions to meet these decisions, and those impacted by these decisions. Community input is needed. That means you. Some of this planning work is already underway. These changes will take place over the next 20 years, but early community involvement is essential to ensure that changes in the valley prioritize the health and well-being of those that live here, you. I want to hear from you. Stay tuned for more information on the upcoming workshops January 13th and 14th to discuss agricultural land repurposing options and your land use preferences to help address groundwater overdraft by 2040. SGMA will take 5 to 10 years to be fully implemented. It is still in its early stages. Here is a way you can become involved early. My goal is to elevate community needs. I want to inform where and how land is repurposed so that it minimizes impacts to farmers and underserved communities. And these decisions are currently being made with or without you. It is better if you are involved and have a say in these decisions that affect you, your family, and your community. Thank you for tuning in. If you have any questions, please ask in the video comments or feel free to send an email to caliwaterag@gmail.com as seen on that screen. And don't forget to hit that like button, subscribe to Cali Water Ag, and share this video with family and friends so that together we can learn more about California water and agriculture. A special thanks to Vice Lab at UC Merced and the Environmental Defense Fund for funding of this project and editorial support.